The first is 1D grid of 1D blocks. The grid here, it is referring to a collection of thread block, and block, it means a collection of threads. So the formula to calculate the thread indices here is block index dot x times block time dot x plus thread idx dot x. I'm not going to read out loud the formulas later. So the blocks index, this one, it is referring to, how to say this? Okay, so first let's draw a picture. How can we visualize a grid? Since it's 1D, it only has x-axis, so this is our grid. And on our grid, there could be block 1, block 2, block 3, and these are the thread blocks referring here. The number of block is restrained and confined by how programmer do the configuration and what's the resources limitation of the GPU itself, which is not within the scope of today's video. And after we have these blocks, these are the block index. Inside each block, there are collections of threads. So if we want to have indices of one thread, the way we calculate and get the thread index is through, we have the block index, like we know how many block it is in front of the block we are currently at, because in CUDA and programming everything starts with 0, so it is this. And nicely, the block index is referring to how many blocks are in front of the current block. And the block name, this is referring to how many threads does one block have. And by timing these two parameters together, we get how many threads in total is before our thread. And if you want to ask me, why do we calculate these two? Why is everything in horizontal here? The two reasons are, the first, you see, it's 1D. And by 1D, it means there's only one direction, so it's horizontal. And the second reason is that not only, even if it is not 1D, when doing calculation and reading data from the memory, everything is horizontal. Even later in these 2D cases, in memory, these data are managed and stored in a horizontal manner. So yeah, I hope I explained very clearly for this 1D grid of 1D blocks example. And if you have any question, please leave a comment in this YouTube channel so I can improve and you can get your questions resolved. Now let's start with the 1D grid of 2D block. So what is this? So what would this be? For 1D grid, it means for grid only 1D fraction, and 2D block, these are the block. But this time, this block will have two dimensions, x here and also y here. The block will have a block name in y direction and the block name in x dimension. A block name basically means how many threads that they have in this direction, and by timing these together, you got the total number of threads. So let's see the formula. Block index times block name x times block name y plus thread idx. So this part, it is calculating the total number of threads in the block that is in front of, like for example, if we are like calculating this thread, so it is calculating how many threads in the block that is in front of the block 2, like, yeah. And thread ID xy times block name x plus thread index x. So what are these calculating? They are actually calculating in this like current block, since there are like two axes, x and y, and for one thread here, there will be like thread in front of it in the current block, and this is the y direction, which is the thread idx dot y. It is like the row indexes, like how many rows is in front of the current thread, times the block name, like how many threads in total that this direction has. And by timing these together, we get how many threads is in front of me in this current block. And then we plus this, which is actually like the column. Like, for example, it would be, if we are like here, this is referring to the thread index y. Sorry, like this is referring to the thread index y, and this is referring to the thread index x. So by doing this calculation, we get our indices in a 1D grid of 2D blocks.